linear relations, and the real connection between slopes and first differences of linear relations. Remember that the slope of a line is represented by a lowercase m, like that, and it represents the change in the vertical distance divided by the change in the horizontal distance, or the change in the dependent variable divided by the change in the independent variable. The words rise over run are used for it, and also rate of change. And remember that rise is going up and down, just like the sun does, and run's going left and right, just like a sprinter would who's in a race. If we look at the linear relation in the graph below, we need to find its slope, and we need to then create a table of values with at least 5 points from the line. And then we need to use the table of values to determine the first differences and figure out the significance or the relationship between the slope and the first differences. First of all, to find the slope, the easiest thing to do is pick two nice points that go through the grid really well. Maybe this point here. And we'll do this point here. It doesn't matter which 2 points you pick. And the idea, we need to go from one point, drawing a horizontal line straight across, to another point, drawing a vertical line straight up. Now, if I look at this, I move 2 points to the right, which is in a positive direction. So my run is +2. And my rise, I moved up 1, 2, 3, 4 in a positive direction. So my slope is just rise over run, which is +4 over +2, which is +2. We don't need to write the over 1, but we do have to remember that it is there. Now, to create a table of values, if I look, there's a nice point here at 0, -2. So I'm going to put that one in my table. And there's another point right here that's nice at 1 and 0. And again, I'm going to add that to my table. And this point here that I already used at 2 and 2. And another point here. I move 3 to the right and up 4 to get to it. So that's the point 3, 4. And the last point I used in my table, I went right 4 and up 6 to get to it. So it's the ordered pair 4, 6. If I look at that, I can see a pattern in my x values. I can see that x is always increasing by 1, and the y's are increasing by 2. Since the x is increased by a constant value, I can actually use first differences to determine if it's linear or nonlinear. Now, I already know it's linear because I can see it, but we are going to see something interesting when we calculate the first differences. So if I go back to the table I had, we'll just put all the x and y values back in. And in order to find first differences, remember, order matters. I need to do 0, take away -2 first, and subtract the negative becomes a positive, and the first difference is 2. The next pair I'm going to work with are the 0 and the 2, and I need to do 2, take away 0 first. And that leaves me 2 also. And then I'm going to work with the 4 and the 2. And again, 4 has to be first. 4 take away 2 is 2. And finally, 6 take away 4 is also 2. So the first differences are constant, which confirms it's a linear relation, but we already knew that. But what is interesting, if I look at my first differences and I go back to my slope, well, wait a minute, those were exactly the same. So what happened was my slope and my first differences were equal. Now, if I look at this linear relation, I'm going to start by graphing it. I've got the ordered pair -2, 5, so I start at my origin, go left 2, and up 5, and I'm going to put a dot there, and -1, 3, so I start at my origin, I go left 1 and up 3, 0, 1. I don't have to move left or right because x is 0, but I do have to move up 1. 1, -1, I start at the origin, go right. I'm going in a positive direction for the x coordinate and a negative direction for the y. And 2, -3, 2 to the right, and 3 down. And then I can draw a straight line. And of course, you'd use a ruler, but I haven't figured out how to get the ruler to work for me on the Mobi yet, so I'm not. You need to find, now you need to find your slope, it says. So I'm going to pick two of my nice points, and I'm going to go from this one here down to this point. Now I move 2 points to the right, which is considered positive, and that's my run because it's like my sprinter. And my rise, I moved in a negative direction. I was decreasing my value, so that's negative. And that's 1, 2, 3, 4. So what is my slope now? Again, I start with my equation. Rise over run. And my rise is -4 over my run, which is +2, which leaves me -2. The next thing it asked us to do was use the table of values to determine the first differences. Now, first we have to make sure that that's a valid strategy, and we have to check, are the x values increasing by a constant value? And if you look, they do go up by 1 each time. So we can use our first differences. And again, order matters, so we're going to start with 3 take away 5, which is -2, 1 take away 3, which is also -2, -1 take away 1, again -2, -3 take away -1 becomes -3 plus 1 because the negative, or the subtract negative, becomes +1. Again, if I look at the first differences, they're -2, and my slope was also -2. So what can I conclude? That they're equivalent. Fabulous. It looks like what happened both times we did that. The slope and the first differences were equal. And in the one part A, slope and first differences were also equal. Let's try it again and make sure it works. So again, we're going to graph this linear relation. So I need to grab a pen. -2, 5. I go left 2, up 5. X is 0, so I don't move up or down. 3, 2, and -1. 4 and negative, oh, there's a typo. 4 and, that's not the right spot. It's not a typo, it's me reading my points wrong. So that point was 2 and 1, and then 4 and -1, and 6 and -3. And again, I'm going to draw my line through, which isn't very straight. Sorry, guys. Eventually, I'll figure out how to draw a line with the Mobi better. Anyway. So I've got my straight line. If I want to find my slope using it, I've got to go from one point on the line to another point on the line. And I always pick nice points to move from and to. So if I look at this one, I'm going in a positive direction when I go from the point -2,5 to the point 2,1. I'm moving in a positive direction horizontally, so my run is positive because my x values are getting bigger. And I went 1, 2, 3, 4 to the right. And my run, I went from a larger y value to a smaller y value, so they're decreasing, and it went down 1, 2, 3, 4. So my run is -4. And again, I always write slope equals rise over run. If I write it out enough, eventually it's going to get stuck in my brain, and I'm not going to forget that formula. So the rise was not +4, but -4. And does everybody else see the other typo I have here? It's not really a typo because I'm writing, but I should say rise there. Sorry about that, guys. So the rise is -4, and the run is +4, which gives me a slope of -1. Excellent. So this means when I use my table of values to find the first differences, that I should get -1 if what we've done so far is accurate. If I look, my x values, do they change by a constant? Yep, I keep increasing by 2. So let's do the first differences now. So 3 take away 5 is -2. That wasn't what we had for the slope, was it? Slope was -1. 1 take away 3 is also -2. -1 take away 2 is also -2. Wait a minute here. The slope and the first differences aren't the same anymore. What happened and why aren't they equivalent? And that's the topic for another day. Before you come to class, please have page 5, number 1 to 3 finished.